While every tech headline right now is about which artificial intelligence chatbot is winning, four companies are doing something completely different. They are not competing for your attention. They are building the infrastructure that intelligence itself will run on. NVIDIA, Tesla, xAI, SpaceX. Together, they represent roughly $8 trillion in combined value, more than the GDP of every country on Earth except the United States and China. And they are not building apps. They are building a vertical stack from silicon to space, and no other entity on the planet can replicate it. Start with NVIDIA, because NVIDIA is generating revenue in a way that has genuinely no precedent in corporate history. Fiscal year 2026, $215 billion in revenue, up 65% year over year. Their data center division alone hit nearly $194 billion. In a single quarter, they generated $68 billion. That is more than Nike makes in an entire year, every 3 months. They hold somewhere between 80 and 90% of the artificial intelligence accelerator market. Their CUDA software has 4 million developers building on top of it. And at GTC in March 2026, Jensen Huang unveiled their next chip, Vera Rubin, built on a 3-nanometer process with 336 billion transistors and promising 10 times the inference throughput per watt of the current generation. But here is the move nobody expected. NVIDIA paid $20 billion for Grok, a startup building chips that are fundamentally different from GPUs. Where NVIDIA's hardware is optimized for training massive models, Grok's architecture is built for inference, running those models in real time, fast and cheaply. Jensen Huang essentially bought a direct competitor to his own product line. The reason? Inference is projected to be 10 times larger than training as a market by 2028. He is not going to let anyone else own it. The combined Grok and Vera Rubin system delivers 35 times more throughput per megawatt than Blackwell alone. That is not an incremental improvement. That is a generational leap in the economics of running artificial intelligence at scale. The threat to NVIDIA is real and worth naming. Google, Amazon, and Meta are all designing custom chips specifically to reduce their dependence on NVIDIA. Stanford's most famous artificial intelligence course recently switched from CUDA to Google's framework as its default. If the next generation of researchers does not learn CUDA, NVIDIA's deepest moat starts leaking. For now, though, NVIDIA does not just sell shovels in the artificial intelligence gold rush. It is the mine. Tesla is the most polarizing bet in this group, and it deserves both sides of the argument. The bull case starts with data. Tesla's FSD fleet has now accumulated over 8 billion real-world driving miles. Waymo, which most people consider the self-driving leader, has logged around 127 million total miles. That gap is not a rounding error. It is a training advantage that compounds every single day as more Tesla vehicles add more miles. FSD V14 runs a neural network 10 times larger than its predecessor. The Optimus humanoid robot is now deployed in Tesla's own factories, making it the largest real-world humanoid deployment in manufacturing history. These are not demo units in a controlled lab. They are working on production lines. The bear case is equally real. The Austin Robotaxi service launched in June 2025. 8 months in, the service had been involved in 14 crashes across 800,000 miles, which works out to worse performance than the average human driver. The National Highway Traffic Safety Administration has multiple concurrent investigations open. And Waymo, despite its smaller data footprint, completes 450,000 paid rides every week across 6 cities. Tesla's data advantage is real and compounding. The question is not whether FSD eventually gets there. It is whether it gets there fast enough to justify a stock currently trading at over 200 times earnings. That is the bet, and it has not paid off yet. Now, for the part of this story that most people have not fully processed, in February 2026, SpaceX completed its acquisition of xAI in an all-stock deal. The combined valuation, $1.25 trillion. The largest acquisition of a private company in history. What that merger creates is something with no precedent. A company that builds the rockets, owns the satellites, runs the artificial intelligence models, and has the distribution network to beam it all to 1 billion people who currently have no reliable internet access. xAI's Grok 4.1 currently ranks near the top of major AI benchmarks. The Colossus supercluster in Memphis was built in 122 days. The industry standard for a comparable facility is 4 years. It now houses 230,000 GPUs, drawing 300 megawatts of power. And xAI has something no other artificial intelligence company has. X, with 600 million monthly active users generating real-time conversation data that feeds directly into Grok's training. But the story that will reshape how you think about all of this is the FCC filing. On January 30th, 2026, SpaceX filed with the Federal Communications Commission for permission to launch up to 1 million satellites designed to function as orbital data centers. The satellites would operate in low Earth orbit at altitudes between 500 and 2,000 kilometers, powered by near constant solar exposure, optimized for large-scale artificial intelligence inference. SpaceX described it in the filing as the first step toward becoming a Kardashev Type 2 civilization, one capable of harnessing the full output of the sun. To understand why this is not just vision, consider the terrestrial problem it is solving. AI data center electricity demand is projected to nearly double by 2030. Grid infrastructure cannot be built fast enough. Power is the binding constraint. Orbital compute bypasses that entirely. Space offers unlimited solar power and natural cooling from the vacuum of space, two things that every data center on Earth is running out of. The engineering challenges are enormous and unsolved. 1 million satellites is a number that dwarfs every constellation seriously proposed by anyone. But SpaceX already has 10,000 active satellites, representing 65% of everything currently in orbit. They have the rockets, they have the launch cadence, and they have a regulatory filing that is now in the public record and moving through the FCC process. Every one of these bets could fail. Musk's timelines are famously unreliable. Tesla's robo-taxi data is weaker than its marketing. The orbital compute vision faces engineering problems that have not been solved yet. NVIDIA faces a real threat as its biggest customers build chips to replace it. None of these companies needs to be right about everything. They each just need to be right about one thing. If NVIDIA holds even 70% of a $1.2 trillion chip market by 2030, that is $840 billion in annual revenue. If Optimus reaches a fraction of its stated potential, it becomes the most valuable product in manufacturing history. And if even 1/10 of the orbital compute vision materializes, the SpaceX FCC filing becomes the most strategically valuable piece of paper filed with any government agency in years. The moats that big tech spent decades building are cracking. The companies building what comes next are already here. If you want to keep following where this is actually going, subscribe and leave a comment. Which of these four do you think has the highest ceiling, and which one worries you most? I want to know what you think.